minus 20 degrees Celsius at the equator. For 100 million years, the entire planet is sheathed in ice, a ghostly white marble adrift in the blackness of space. Life, pushed to the very brink of annihilation, clings to existence in volcanic vents and sun-warmed pockets of water. Then, after an epoch of silence, the ice retreats, and in its wake, an explosion. The single most powerful eruption of biological diversity in the 4.5 billion year history of Earth. This was not in spite of the ice, it was because of it. The planet's deepest freeze was evolution's greatest gift. The popular imagination conjures images of shaggy mammoths and hunters clad in furs, of vast tundras and imaginable scale. A true ice age is a planetary transformation. When global temperatures plummet, ice sheets kilometers thick begin to grow, entombing entire continents. North America, Europe, buried under a weight that depresses the very crust of the Earth. But the most profound changes occur far from the ice itself. As trillions of tons of water are locked away in these continental glaciers, the world's oceans begin to recede. Sea levels fall by hundreds of feet, exposing the seabed. What were once islands become mountains in the midst of vast, dry plains. Straits that separated continents become solid land, creating bridges for migration. It was on such a bridge that humans, a mere 12,000 years ago, could have walked from the lands we now call Russia to Alaska. The map of the world is redrawn. And with the cold comes an even greater challenge: drought. A colder atmosphere holds less moisture, and rainfall becomes a rarity. The world, even in its unfrozen regions, becomes profoundly arid. The Amazon, that icon of lush, eternal rainforest, withers into a dry savanna. The great ice ages were not just ages of cold, but ages of thirst, of dust, and of desolation. We exist today in what scientists call an interglacial, a brief warm pause between these immense periods of cold. It was the puzzle of these cycles, discovered not through ancient records, but through the geological detective work of the 19th century, that reshaped our understanding of Earth's history. And it is in this history that we find the ultimate paradox, that the near-total extinction event of a snowball Earth created the perfect crucible, the intense envy catalyst for the Cambrian explosion, the moment life discovered the blueprint for almost every animal body plan that exists today. The ice had to nearly kill the world for complex life to truly be born. There was a time, not so long ago, when the very notion of a radically changing climate was unthinkable. The Earth was perceived as a stable, almost immutable stage upon which the drama of life unfolded. Our sense of its history was profoundly limited, a narrative confined by scripture to a mere 7,000 years, or stretched by the speculative minds of astronomers to perhaps a few hundred million. The prevailing story of our world was one of majestic simplicity. It was a planet born of fire, a molten sphere cast into the void, engaged in a slow, inexorable process of cooling. And there was evidence, seemingly etched in stone, to support this grand, simple idea. In the high northern latitudes, where the cold was a constant companion, geologists unearthed the bones of creatures that could only have lived in warmth. Vast, cold-blooded reptiles. In the frozen soils of Scandinavia and the Russian expanse, they found the fossilized remains of lush tropical plants. The logic was as solid as the frozen ground itself. The past was warmer, the present is colder. Therefore, the planet must be cooling. It was an elegant theory, a straight line drawn from a fiery beginning to a frigid, distant end. This entire worldview was shattered by the work of a single man, Louis Agassiz. In the year 1837, he published a revolutionary treatise, a theory of glaciers that would forever alter our understanding of the planet. Agassiz gathered the disparate, cutting-edge geological findings of his time and synthesized them with an ancient, unspoken knowledge, a wisdom held by the mountain peoples of Scandinavia for generations. They knew that glaciers were not static monuments of ice. They grew and they retreated. They moved. And as they moved, they left behind an unmistakable signature upon the land. What were these signatures? They were colossal boulders, known as erratics, stranded in the middle of flat fields, hundreds, even thousands of kilometers from the mountains they were torn from. They were deep, parallel grooves carved into the hardest bedrock, scars gouged by the immense pressure of ice dragging stone over stone. They were vast seas of rock and debris deposited in places where no mountain peak had stood for eons. This was more than an observation, it was a revelation. Agassiz demonstrated that our planet was not merely cooling, it had been subjected to violent oscillations, to entire epochs where vast sheets of ice had consumed the continents. The Earth had not just grown colder, it had been locked in a deep and profound freeze. The scientific establishment of the day met this idea with a reception that was, fittingly, ice-cold. One must imagine the scene in the learned societies of Europe. Here was a man claiming that a wall of ice, perhaps 100 meters thick, had once ground its way over the future sites of Paris and St. Petersburg. To the 19th century mind, this sounded less plausible than the biblical myth of a great world-cleansing flood. It was a vision of a world too brutal, too alien to accept. Yet the evidence was relentless. As geological science matured, the case for the ice ages became undeniable. By the end of the 19th century, the Scottish scientist James Croll had meticulously defined the criteria for distinguishing glacial deposits from all other geological formations. He gave scientists the tools to read the story written by the ice. Then, at the dawn of the 20th century, came the great breakthrough. A Serbian geophysicist, Milutin Milankovic, building upon Kroll's foundations, devised a breathtakingly precise mathematical model. He demonstrated that subtle cyclical variations in the Earth's orbit around the Sun, its tilt, its wobble, and the shape of its elliptical path could precisely predict the comings and goings of the great ice sheets. The mechanism of the ice ages was finally being unveiled, and the answer to the question of what triggers them was far more intricate than anyone had dared to imagine. There is no single cause, no lone switch that plunges the world into frost. Each ice age is a unique confluence of factors, as individual as a fingerprint. It often begins with a change in the planet's reflectivity. The principle is simple. As forests recede, more of the land is exposed. In winter, this bare ground becomes covered with a blanket of snow. This vast white shield does not absorb the sun's energy. It reflects it directly back into space. Heat that would have warmed the soil and the air is lost forever. The planet cools. This cooling allows more snow to fall and to persist, which in turn reflects even more sunlight. A feedback loop is born, a self-reinforcing engine of cold, powerful enough to summon glaciers from the poles and send them marching across the face of the Earth. The ice is a reminder that the world we inhabit is not a permanent stage, but a living system of immense power, with rhythms that dwarf the span of human memory. It tells a story not of a planet in decline, but of one locked in an eternal dynamic dance with the cosmos, a world of fire and of ice. The Earth's climate is governed by a delicate balance, a planetary thermostat set by the composition of its oping and scattering the sun's warmth. When their concentration falls, the planet inevitably cools. But the triggers for these profound shifts are not always terrestrial. They can be found in the silent clockwork machinery of the cosmos itself. Here, we enter the realm of a brilliant insight, a theory conceived by the Serbian scientist Milutin Milankovic. He understood that our planet's climate is not a constant, but is instead subject to three immense overlapping cosmic cycles. These are the great pacemakers of the ice ages. The first of these grand celestial rhythms concerns the shape of Earth's orbit. Over a period of roughly 100,000 years, its path around the Sun slowly shifts from a near-perfect circle to a more pronounced ellipse. Milankovic calculated that during a more oval or eccentric orbit, our world receives less total solar radiation during its winter passage, allowing for a deeper and more persistent chill to take hold. The second cycle is a change in the tilt of our planet's axis. With a periodicity of 41,000 years, the Earth wobbles, altering its inclination. A greater tilt means more extreme seasons, scorching summers and frigid winters. But as the tilt lessens, summers become milder, unable to melt the previous winter's snow and ice. Over millennia, this accumulation allows glaciers to be born and to begin their inexorable advance. The third cycle, a slower wobble of the axis known as precession, determines the timing of the seasons themselves, dictating which hemisphere faces the Sun at the closest point in our orbit. This subtly redistributes solar energy across the globe. In regions starved of light, the ice begins to grow. These forces reveal a fundamental truth. Our climate is in a state of constant, gradual flux. By the measure of a human lifetime, the change is imperceptible. But across geological deep time, this same planet has been both a sweltering tropical paradise and a desolate frozen hell. Yet even these epic cycles are but a prelude to a story so extreme, so utterly wild, that for decades the scientific community struggled to accept it as truth. It is the story of the most profound ice age in our planet's history, an event that began some 750 million years ago. Geologists have given this era a chillingly appropriate name, the Cryogenian, literally the birth of ice. During this period, the Earth did not just have polar ice caps. It was entombed. A shell of ice, perhaps kilometers thick, stretched uninterrupted from pole to pole, covering every continent, every ocean. This was the era of Snowball Earth. For nearly 100 million years, our world was a gleaming white sphere, a ghost planet suspended in the dark of space. How could such a catastrophe unfold? It was the result of a unique and devastating confluence of geological and chemical events. In this distant past, the primary source of atmospheric carbon dioxide was volcanic activity. But this gas was being systematically stripped from the air by a process of chemical weathering of rocks. And crucially, due to the slow dance of plate tectonics, all the world's landmasses had drifted together to form a single supercontinent, Rodinia, situated directly upon the equator. This equatorial position was the fatal flaw. The warm, wet tropics dramatically accelerated the weathering process, pulling carbon dioxide out of the atmosphere and locking it away in carbonate rocks at an unprecedented rate. The planet's thermostat was broken. With the thermal blanket of greenhouse gases growing ever thinner, the cold began to spread. Ice sheets advanced from the poles, their white surfaces reflecting sunlight back into space, accelerating the cooling in a runaway feedback loop. The planet froze. At the equator, on the hottest day of the year, temperatures plummeted to -20 degrees Celsius. It was a world of profound silence, a boundless ice desert stretching on, clinging to existence in the warm oases around deep-sea volcanic vents. But even in this frozen purgatory, the planet's inner fire had not been extinguished. Beneath the ice, volcanoes continued to rumble, steadily venting carbon dioxide into the atmosphere. The very ice sheet that had sealed the planet's doom now became its savior. By covering the rocks, it had stopped the chemical weathering. There was no longer a mechanism to remove the CO2. For tens of millions of years, the gas accumulated, its concentration rising to hundreds of times modern levels. An unimaginable greenhouse was building, trapped beneath a planetary lid of ice. The stage was set not for a gentle thaw, but for a violent awakening. The Earth was a pressure cooker, waiting to explode. The Great Thaw began. As the ice retreated from a world locked in a planetary deep freeze, the supercontinent of Rodinia, a single immense landmass, started to groan and fracture. Its vast, sterile interior, for millennia shielded by ice, was now laid bare. And as its fragments drifted apart, they were exposed to the full force of the atmosphere. Torrents of rain, falling upon uncharted rock for the first time in an eon, began a process of dissolution, carrying a precious cargo of life-giving minerals, phosphorus and carbonates, and washing them into the primordial oceans. This planetary-scale fertilization event became the catalyst for a revolution. In the geological blink of an eye, life ignited. It is known as the Cambrian explosion, but its first chapter was the skeletal revolution. For deep within the fossil record, in the layers of rock corresponding to this exact period, an unprecedented phenomenon occurs: the sudden, dramatic appearance of skeletons. Hard parts, shells, and carapaces emerge as if from nowhere. a testament to life arming itself, building complex structures from the new abundance of oceanic minerals. Life had not only survived the longest, most severe ice age in Earth's history, it had used the aftermath as a springboard to conquer the entire planet. It is a profound and unsettling paradox that the most devastating glaciation our world has ever known was not an end, but the prologue to the greatest proliferation of biological diversity. The ice, it seems, created the very conditions for this ancient pattern of ice shaping life echoes through time into an era much closer to our own. We can journey to a world of ice so recent that its chill can still be felt in the genetic memory of our species. This was the world of our direct ancestors, the last great glacial period, known in Eurasia as the Weichselian glaciation. Its name in the east is derived from the Valdai Hills of central Russia, where geologists first deciphered its immense footprint. It was a period that began over 100,000 years ago, but ended a mere 12,000 years in our past. A heartbeat in geological time. Modern humans, anatomically identical to us, walked this Earth. This was their world. To see it is to see a planet that is both familiar and profoundly alien. Colossal sheets of ice, a solid mass 2 to 3 kilometers thick, ground their way south from Scandinavia, burying the land as far as the site of modern-day Moscow. In North America, the Cordilleran and Laurentide ice sheets merged into a single continent-spanning shield, a high wall of ice stretching to Labrador. The global climate was, on average, 6 degrees Celsius colder, but more significantly, it was intensely arid. A vast portion of the planet's fresh water was no longer in circulation. It was imprisoned as ice. Yet beyond the frozen margins, the world held stunning surprises. In Siberia, a name now synonymous with extreme cold, there were almost no glaciers. The air was too dry for significant snowfall. Where the ice ended, boundless tundra steppes and sparse woodlands stretched to the horizon, eventually fading into vast deserts. The great equatorial rainforests we consider timeless, the Amazon, the Congo, were diminished, fragmented into pockets of woodland separated by sprawling savannas. And in a breathtaking inversion of our expectations, glaciers clung to the high mountains of the equator. The central spine of New Guinea and the Andes of Peru and Bolivia became local centers of glaciation, ice under a tropical sun. As this immense weight of water piled up on the continents, the oceans were starved. Sea levels plummeted, falling by an astonishing 120 meters. Imagine standing on a coastline today and seeing the water recede to reveal a hidden landscape the height of a 40-story skyscraper. The map of the world was redrawn. Islands became mountains on vast new plains. Shallow seas became landlocked valleys. The British Isles were not islands at all, but a rugged northwestern peninsula of Europe. One could have walked from the hills of what would become Paris, across the cold, windswept valley of the Channel River, and onto the chalky highlands of ancient Britain. This lost world is not a fantasy. It is a physical reality, a world shaped by the power of ice, whose coastlines are now drowned and whose land bridges are submerged. It serves as a stark reminder that the geography we take for granted, the very shape of our continents and the placement of our shores, is not a permanent fixture, but a fleeting arrangement in the long, cyclical breathing of our planet's climate. The world we inhabit is merely the interlude between one great age of ice and the next. In an age of ice, the map of the world was fundamentally different. Global sea levels, locked away in colossal glaciers, had fallen dramatically, revealing a landmass where today there is only the turbulent water of the Bering Strait. This was Beringia, a vast frozen bridge connecting the continents of Eurasia and North America. This single geological feature, this intercontinental artery, would rewrite the very story of life on two continents. Through this corridor, a great biological exchange began. Wolves, the ancestors of the loyal companions by our side today, streamed into Eurasia, their destinies forever altered by a future encounter with humanity. From the Americas, horses and camels journeyed west, their descendants eventually spreading across the Old World. But the most consequential journey was eastward. Across this frozen bridge, the first humans set foot in a new world, beginning a story of settlement and survival that would span millennia. One might imagine such a radical reshuffling of life would inflict a catastrophic blow upon the world's ecosystems. And in part, it did. But a profound paradox was unfolding. For the sprawling steppe environments, the dry, frigid climate of the glacial period was not an age of death, but an epoch of unprecedented flourishing. A biome that no longer exists anywhere on Earth was born. The tundra steppe. Its inhabitants, a menagerie of giants, would be named for their most iconic member, the mammoth fauna. Close your eyes and picture a world now lost to time. From the western shores of Europe to the edge of the Pacific, an unbroken plain stretched before the eyes of ancient man. It was a true ocean of grass, rippling under a relentless wind, its horizon disturbed only by the occasional shrub or a sparse line of trees clinging to a riverbank. The winters were severe, yet dry, with little snow. This crucial detail made the paradise of vegetation accessible to herbivores all year round. In its sheer biological productivity, the tundra steppe rivaled the modern African savanna, and it fed a population of Among them was the woolly rhinoceros, a quintessential beast of this lost world. Weighing up to 4 tons, it resembled its modern relatives but was cloaked in a thick reddish-brown mantle of fur, a perfect defense against the brutal cold. Its gigantic horn, longer and more powerful than any seen today, was not merely a weapon. It was a specialized shovel, a natural plow that the great beast used to sweep aside snow, clearing a path to the frozen grasses beneath. And then, the titan of this age, the mammoth. These immense, shaggy behemoths roamed the endless fields of grass in great herds. For the ancient humans who shared their world, they were walking citadels of resources. A single successful hunt was a monumental event, providing a whole tribe with a bounty of meat, fat, and marrow that could last for months. Its bones were the raw material for tools and shelters. Its thick hide, a shield against the unforgiving elements. The world was not only for giants. Thundering herds of steppe bison, ancestors of both the American bison and the European wisent, gathered in congregations tens of thousands strong, their constant migrations carving paths across the continent in a relentless search for untouched pastures. Alongside them grazed the ancient progenitors of modern horses and deer, each a vital thread in this complex ecological tapestry. Where there is prey, there must be predators. The Siberian tundra steppe was the cradle of the modern bear, the ancestral homeland from which they would later radiate across Europe and into the Americas. Here, too, hunted the ancestors of today's great cats, the formidable cave lions, beasts that surpassed their modern African cousins in both size and power. But of all the inhabitants of the tundra steppe, the most unusual and ultimately the most dangerous was a newcomer. Small nomadic clans of Pribe, the megafauna they pursued, yet their intelligence, their cooperation, and their developing technology made them the true apex predator of this icebound world. This was the planet before our own, a world forged in ice, sustained by grass, and ruled by giants. It stands as a testament to life's tenacity in the harshest of climes, an entire chapter of Earth's history now silenced, surviving only as whispers in the frozen soil and faint echoes in our own DNA. Across a world of ice they advanced, colonizing new frontiers of an unforgiving planet. In the pale Earth, where paleontologists now search for clues, their story is etched in bone and stone. Human settlements scattered across the vast, windswept tundra steppe, a lost continent of grass and frost. Here, we find the ghostly architecture of a forgotten age, huts framed with the colossal bones of mammoths and woolly rhinoceroses, monuments to their ingenuity. We unearth the first crude sculptures, the faint impressions of clothing made from hide, and even jewelry, delicate testaments to a desire for beauty in a brutal world. The people of the Ice Age were not mere survivors huddled against the cold. They were artists, creators, and dreamers, leaving their mark on a world that was already doomed. The end began some 20,000 years ago. The final great glaciation was losing its grip. But how does a world of ice die? The answer lies in a profound paradox. a mechanism scientists call a feedback loop. The very consequences of the global cooling were destined to trigger a global warming. The colossal ice sheets, in their relentless expansion, had locked away so much of the world's water that the sea level had plummeted. As the oceans receded, vast frozen continental shelves were exposed. Methane, a potent greenhouse gas, long trapped in the frigid depths and frozen sediments, began to bleed into the atmosphere. This slow, inexorable release of methane ignited a planetary chain reaction. A greenhouse effect took hold, and the ice began its long retreat. As the great white shields of the glaciers shrank, they exposed the darker land and sea beneath. The planet's ability to reflect solar heat was diminished. The Earth, stripped of its white mirror, began to absorb more and more of the sun's energy, accelerating the thaw in a relentless, self-perpetuating cycle. By 10,000 years ago, the face of our world was transforming into one we might recognize. The majority of the glaciers had vanished, their meltwater swelling the seas. Oceans reclaimed their territory with astonishing speed, swallowing land bridges that had connected continents for millennia, carving new straits and birthing new islands. The planet's ecosystems were rewritten. Savannas bloomed into equatorial forests. The endless tundra steppe surrendered, its grasses and hardy shrubs replaced by the deep green of the taiga. The remnants of the mammoth fauna, the great beasts of the ice, scattered and adapted, their descendants now living in ecosystems so different it is difficult to imagine their shared ancestry. It is a world where musk oxen once grazed near the Saiga antelope of the Kazakh plains, a world where the horse had not yet found its way to Africa or Europe. The world had changed, utterly and completely, and what is vital to understand is that it will change again. This is where the study of the past becomes a terrifying forecast for the future. We can now model the intricate dance of our planet's climate with frightening precision, and the data reveals a chilling irony. The very global warming that defines our era, the warming we are accelerating, may be the trigger for the next great freeze. The mechanism is deceptively simple. The melting of the polar ice caps is not just raising sea levels, it is pouring a deluge of fresh water into the North Atlantic. This infusion of fresh water is a poison to the engine of our climate, the great ocean conveyor known as the Gulf Stream. This immense current, a river of warmth within the ocean, carries heat from the equator to the poles, giving northern Europe a climate far milder than its latitude would suggest. Should this current slow or stop entirely, Europe, despite a warming planet, could be plunged into a brutal, localized ice age. It is the paradox of a complex system where one extreme can unexpectedly give birth to its opposite. Perhaps we will be ready. Our technology, our deepening understanding of climate, our ability to plan for decades ahead, all of this offers a sliver of hope. But a more profound question haunts the silence between the data points. Have we acquired the wisdom to match our power? For millions of years, the Earth's climate danced to the rhythm of cosmic cycles and geological time entirely without our influence. But now, we have become a factor in the equation. We are a geological force in our own right, a species that holds the thermostat of its own world, capable of accelerating or decelerating changes that once took millennia. It is a power we never asked for, and a responsibility from which we can no longer turn away. There is a profound contradiction at the heart of our world's story, the staggering fragility of life and its unyielding resilience. Imagine a planet entombed, a sphere of white and blue, locked in a silence so deep it spans millennia. Not for a season, but for millions of years, the Earth was almost entirely encased in ice, a planetary jewel of rime and frost, where the sun's warmth was a distant, powerless memory. By all logic, the delicate experiment of life should have been extinguished, its faint spark snuffed out beneath kilometers of glacial ice. But it was not. In the crushing dark of the abyssal plains and in tiny sheltered pockets of geothermal warmth, life clung on. Around volcanic vents, in oases of chemical heat, a tenacious few endured. They were the keepers of a legacy, the silent promise of a world to come. And when the great thaw finally arrived, when the ice retreated in a planetary exhalation of steam and meltwater, life did not simply recover, it erupted. Eons later, the cycle would turn again, giving rise to a world of titans. This was the Pleistocene, an epoch of ice, wind, and colossal beasts. Shaggy behemoths, the woolly mammoths, moved in great herds across landscapes of permafrost, their tusks carving arcs through the frozen air. In the shadows of these giants, a new and audacious primate watched. Human beings, armed with little more than sharpened stone, fire, and a nascent burning intelligence, hunted these impossible creatures. They lived and died in a world of lost ecosystems, a tapestry of life woven from cold and struggle, now vanished from the earth forever. All of it, the deep freeze, the desperate survival, the age of megafauna, is but a single chapter in the immense story of our planet. And we today are living in one of its most peculiar passages. We call it the Holocene, but in the grander scheme, it is known as an interglacial, a warm breath between two colossal freezes, a fleeting geological summer. The great cycles of the planet, governed by the subtle wobble of its axis and the intricate dance of its orbit, are relentless. They are as inevitable as the turning of the seasons, but on a scale that defies human comprehension. Thousands, or perhaps tens of thousands of years from now, the ice will return. This is not prophecy, it is planetary mechanics. Until that moment, we have been granted time. Time to study, to comprehend, to prepare. Time to learn how to live in concert with the astonishing forces that have shaped our very existence. So the next time a winter chill bites at the air and we complain of the cold, it is worth pausing to consider the alternative. Imagine a sheet of ice 3 kilometers thick, grinding silently where our cities now stand. Picture the oceans of the world diminished, their levels fallen by 120 meters, exposing vast new coastlines on a transformed globe. Before you, endless steppes would stretch to the horizon, grasslands populated by herds of mammoths and stalked by the shadows of saber-toothed cats. To witness such a world would be an awe-inspiring, terrifying spectacle. To stand in this brief, warm moment of the Earth's history is to be gifted with a unique perspective. We are perhaps the first species capable of reading this planetary history, of looking back into the deep past and seeing the rhythmic pulse of ice and thaw. Our challenge, then, is not to fear the inevitable turning of the world, but to understand the sheer scale of the stage on which our brief act unfolds. And in that understanding, to find a deeper, more profound harmony with the indifferent, beautiful, and terrifying planet that gave us life. In the lost epochs of our world, life took forms both alien and strangely familiar. Dinosaurs, cloaked not in scales, but in primitive feathers, stalked ancient forests. In the humid, oxygen-rich air, arthropods swelled to nightmarish proportions. Yet this vibrant world was built upon a knife's edge. A planet that once nearly suffocated, its atmosphere almost entirely stripped of the oxygen that makes our own existence possible. Beneath the foundations of our modern cities lies a deeper memory. Where skyscrapers now stand, herds of woolly mammoths may have once grazed on frozen plains. Or perhaps there was nothing but the immense, crushing weight of a continental glacier. In the vastness of Siberia and Alaska, that past is not entirely gone. The landscape itself is a relic of the Pleistocene, a world changed only by the absence of its vanished giants. We live in a fleeting, warm interlude, a brief summer between ages of ice. The land remembers, even if we have forgotten.